Hello guys, in this lesson we will define the controller approach, okay? Because we need to drive our system into the specific points, which means that we give the x reference value to this system, and then we want the system to drive whole x values to this point, which is called the reference tracking problem, okay? And so we have the title in here, controller design in linear system, okay? And then what? Firstly, let the system be in here x dot is equal to the I minus a times x plus b times u, okay? But however, we cannot be sure about what is the value of a and b, and so since they are unknown parameters and so then the estimator model should be utilized by using the what, or in summary, we don't know unknown parameters a and b in here, like this one, and so we need to utilize the the x dot equal to the the a hat times x in here, x plus b hat times u, okay? We don't know what's the value of the a and b. X can be measured and U can be calculated by the controller designs, but in our controller designs we should utilize or use the A hat and B hat values, because we can estimate the R values, or we can obtain this value from the estimator model. And so in the controller design we should specify all the linear term or the constant value, and then in microprocessors or your computers we should use these coefficients, because we don't know what's the exact value of the a and b, and so your controller design should be included this a hat and b hat value, okay? Because we don't know or we don't obtain this a and b value, okay? And then what? After that, we should define the reference tracking problem, or we should give the stability rule in here, okay? How can we obtain the stability rule at this moment? So, firstly, we need to define the error value or error variable in here, like this one. Let the error be should be included in here. A or E is equal to the x ref minus x, and E dot is equal to the x ref dot minus x dot. We should get the derivative of the error terms in here, because in our dynamics is included in the x dot. Suppose that if we have a x dot dot or second derivative terms in here, and so we need to obtain the x dot dot in the error dot dot terms, okay? And so we should get one more derivative terms in here, but in our system it's a first order system, and so the E dot is sufficient to design the specific controllers, okay? And so we need to use the E dot term with the Lyapunov rules, okay? Lyapunov dictates us to what we can define the positive energy function in here, like this one. Okay, V and T should be given at this moment. Okay, and so if we have a V or V value in here like this one, if this value is always positive and goes to the 0, and then our reference is okay, because the error should be goes either in here goes to the 0, and then we can say that if the error is 0 and then the x ref and x is equal to the each other. Okay, and so which means that we can drive the system parameters or measured parameters x to the what? To the x reference value. And so we need to define a specific function body or energy function in here like this one, and then in order to create this decreasing energy function or body or dynamics in here, we should also guarantee that the v dot value should also be like this one. And so this is always greater than positive or 0, and so the v dot should always be smaller than 0, and then the v or the total energy is given at this moment goes to 0 at the infinite value of the time. Okay, and so this is the basic rules of the Lyapunov given by in the 1911. Okay, and then what? If we have this kind of information in here, this is the first step, and the second steps taking derivative. 1 divided by 2 times e dot times 2. Okay, and so v dot is equal to the e times e dot. Okay, or in other sense we can write it down as e times x dot should be given at this moment. And so we have the x reference value dot in here and minus x dot, and so plus a hat x minus b hat u. Okay, but we should also say that the x dot is not equal to this one. This should be used at this moment because we don't know the a and b, but we can estimate or we can approach these terms into the what? Into the state equation, because we can estimate the a hat and b hat value. Okay, this is our specific terms to what? To complete the Lyapunov term, and so this always be smaller than the what? The 0 value. Okay, these are the priority condition. And then what? If we have this kind of equation in here, and so v dot is equal to the what? The e times x ref dot plus a hat x minus b hat u should be smaller than 0. And so how can we obtain or how can we select the proper u value in order to what? In order to satisfy this condition, because the x should be measured x ref dots coming from the reference value and a hat and b hat coming from the what? The estimator models. And so we can only organize or we can only choose different as the u or input value in here. In this techniques I can give the some techniques in here like this one. If I have this kind of equation in here, and so I can equalize this term into the what? Minus k times a, and with the what? With always positive k value or coefficient of proportional coefficients in here. And then our system is equal to the what? V dot is equal to the minus k times e square. Okay, and so this is always smaller than the what? The zero value. Okay, because it's positive and it's positive, and so the minus 1 is in front of this equation, and so this always be negative. But the e, if the e goes to 0, and this is approaching to what? Approaching to 0 value in here. Okay, as well as this system should be defined at this moment, and so the stability rule can be given by this one. Minus k times e is equal to the what? The x ref dot plus a hat times x minus b hat times u. Okay, and so if I push all the terms in here like this one, b hat times u is equal to the what? X ref times dot plus a hat x plus k e, and so we have the u value in here. U is equal to the what? X ref dot plus a hat times x plus k a divided by b hat. Okay, in the last form we have u is equal to the what? X ref dot plus a hat x plus k times e divided by b hat. Okay, this is our main approach to what? To guarantee the stability by using the Lyapunov function. And so important to notice that we have some specific notes in here in order to what? In order to the both an estimation and the controller approach is okay in here like this one. We should say that notes can be given in here. We should have the precaution about the selection of the initial value. Select the whole initial value in what? At equilibrium point. In both the controller and estimator approach, it's important to select that. Okay, and so we should give the different reference value, which means that the time response should be much more average or different from each other in itself. Okay, and so if we have the difference of reference value at this time, and so a hat and b hat is much more satisfactory to what? To design or apply the controller rule on this system. And so in the next lesson we will create some controller approach on the MATLAB Simulink application, and then the performance criteria should be evaluated by using these both two terms, examining to what? Estimator coefficients a hat and b hat, and selection or providing the calculation the u value on this system. Okay.